Thank you. So this talk is called, thank you. Upfront applause, perfect. This talk is called Git meets linked data, presented at BobConf 2026. My name is Markus Schlegel, and I work for Active Group, which happens also to be the organizer of Bob. Now, all of these sentences on this slide, you understood them, you're intelligent human beings. But let's say you want to deterministically process them by machines, by software, then they're not in a great shape, right? For example, presented at, that's not even a sentence. We would like to have sentences on a slide. So presented at, it's missing a subject, right? Sentences have subject, verb, object, or sometimes called subject, predicate, object. And presented at, what is presented at? Well, also this talk, right? So we should probably fix that. And then my name is, and I work for Active Group. Well, it's also talking about the same thing, namely me, but syntactically my and I is also a bit unsatisfying. So let's fix that. Oh, and also the fourth sentence with the parentheses, right, this one, the organizer of Bob. It's also not a sentence, but it should be a sentence, I think. And the sentence should be, Active Group is the organizer of BobConf 2026. Still not better, so everything is now a sentence in subject, verb, object form, but still not great for machines to deterministically read. Let's forget about LLMs for this talk. Because there's context involved, right? This talk refers to this talk happening now. If I were to leave this slide deck open for the next speaker to come on, it would no longer be a fact, it would be a lie, because their talk is not called linked data, and they're not called Markus Schlegel. So we should be more explicit in that for the machine, for the dumb machine. And we do that by introducing, for these resources, introducing a name. And it has to be universal, something like a universal resource name, I think, would be fine. Right? Universal resource names look like this, URN, and then I just came up with a short identifier here for the sake of brevity. And we can use that in the subject position of the first two sentences. Now it's very clear what they talk about, and that they talk about the same thing. URNs are the lesser-known sibling of URLs, which both are URIs. And we'll see URLs later on as well, don't worry. We can do the same thing for me. I means Markus, so I invented a universal resource name for myself. Should probably be a UUID or something. Just bear with me for now. This is for the talk. And then Active Group is the last thing missing, and that appears in the subject position of the last sentence and also as the object in the sentence before. And now it becomes clear that these two sentences talk about Active Group, the same thing. And while we are also transforming objects, let's do it with the other objects as well. So there's BobConf 2026 mentioned twice, make that more explicit as well. And then the only objects left are names, and names are no longer resources. Doesn't make sense to give them names. These are just strings, and we use the usual quotation marks to signify that. And now the only black font left on this slide is these predicates, or the verbs in the middle. And we can also make them more explicit. And we can also invent our own names for that, but somebody else already did that. For example, somebody at the website schema.org, there's a large vocabulary of pre-existing predicates that we can just readily use, right? There's one for name, and now these are URLs, which are also perfectly fine URIs, so identifiers that we can use to be explicit about things. So there's one for name, super event I chose for this being a part of Bob, and works for my relation to Active Group. And now this makes up a knowledge graph, or a graph at least, right? You can draw graphs graphically. And I think at the latest point here in this display, you may notice there's some vital information missing, which I just left implicit in its entirety. Do you want to tell?
It doesn't say that you're giving the talk.
Right, perfect. So I drew it like that. There's still some link missing. I'm the performer of this talk. I don't just happen to be some guy working at Active Group, which also happens to be the organizer. No, I am the performer. And that's what I really wanted to say with the first slide, right? So that was missing. So all of that, so that's what's referred to as a knowledge graph, and that's this core idea of the concept of linked data or semantic web. There's probably a difference that I can never remember. I use these two terms interchangeably, and this book is quite good in telling you all about these concepts. So linked data, semantic web, this is the abstract idea of how to work with these knowledge graphs. And then there's a technical implementation that's called Resource Description Framework, RDF. And we already saw one of the notations that you can use that's called N triples on the previous slides, a technical implementation. So these ideas of the semantic web, they came into existence, I think, in the mid-2000s when the human web was matured enough, and people were happy with this concept of being able to go from website to website and process information as a human. But people thought maybe that's great for machines to also have, right? The machines also want to process information, but we have to do something about that. We can take the principles of the web and make them more suitable for machines, and that's what this semantic web is about. But for my work on this project that I introduced in a few moments, what stood out for me is that I think it's quite a nice flexible data model. So if you don't quite know the shape of what's going to happen in your software, but you still want to enforce some structure because otherwise the software wouldn't have to exist, right? You want to do some things, but you still don't quite know what exactly, then maybe this, these semantic web ideas are also applicable to your domains. Because it decouples, right, this vocabulary of what predicates can I use from other concerns. Okay, and then one more quick word on this distributed idea. So it's not just a knowledge graph, it can also be a distributed knowledge graph, meaning that I, as the one submitting a proposal to BobConf, I can say my talk, so this GIML talk down there, has a name, and it's Git meets linked data, that's the name. So I'm the green teal information source. But I don't know if the conference will accept my talk, and if it accepts my talk, where it will be placed, in which room, and in which slot in the schedule. That's not my business, someone else's business. But someone else can talk about the same GIML talk identifier and attach other information to that. And now we have a distributed knowledge graph that we can run one query against. And the parties just have to agree on these identifiers and on not much else. Okay, so onto my project that I was working with my colleagues in basically 2025, the entirety of last year. That's called Social Prescribing EU. It's a European Commission funded research project by now about social prescribing. Now, what is social prescribing? I just noticed that the graph here on their website is actually quite nice to explain that, but it's a bit weak on the slide. So social prescribing means, so at least in Germany, the current healthcare system is based around general practitioners' offices. So patients go to their general practitioners with their medical issues, and then they are treated either by referring to some other medical expert or by directly prescribing the medical treatments, for example. But it happens that often people go to their doctors, to their general practitioners, not because they have primarily a problem with their health, but a problem with their social, with loneliness, for example. Right? So some elderly woman's husband just died, and all of her social contacts vanished from one moment to the other. She goes to her doctors, but he or she, the general practitioner, cannot really do anything about that. Of course, he can, on his own time, can do something about this, but not as in his role of general practitioner. So there's a bit of a gap here. And the social prescribing scheme wants to fill this gap with a new role, which they call the link workers. They're also associated with a general practitioner, but they can work on these social issues, and they can refer the patients to, for example, a chess club if they're interested in chess, and they can even prescribe them the membership, and health system will pay the fees for that, maybe. It's not quite clear yet, but so it's a research project, so they want to find out if this is a good thing to have. And our role was to provide software supporting these link workers in their work. And now you know everything I knew at the start of the project. So there was a huge part of this was requirements engineering, and also a huge part of that was to find people that somewhat fit this role description, which does not yet exist, right? They don't exist yet, but still we had to talk to some people about their software needs. And we found some, and they had lots of good ideas, but the ideas they had for what they wanted to, like how they would want to use the software to support their work, it all was based around information management, but the shape of data they talked about was very diverse, very heterogeneous, and the landscape of where that information originated was very decentralized, you could say, right? Local municipalities, often they provide PDFs where lots of good information is listed, but you have to really know about that. And they certainly don't publish it in a human-readable format, machine-readable format. So I remember, like thinking about this problem for a while, I remember that there's this semantic web craze that happened just when I sort of got interested in the web proper in the mid-2000s. And I remember that, and I thought maybe that's a good fit, because as I said, it decouples sort of the two phases of, or there's two phases of information shaping. RDF itself, the infrastructure, it provides some structure, but it doesn't prescribe what you can talk about specifically, and maybe that's a good fit for this project as well, because yeah, we don't know yet. It's a research project. We don't quite know what's useful to talk about here. So the things that they talk about would be like organizations or locations or events or lists of process steps that you have to follow, or contact persons that you can, people that you can contact for specific issues, stuff like that. But I think most of them, even in the schema.org vocabulary, you can find some predicates that match quite good to what they want to express. Okay, now for a little demo. What that looks like. So here's the application. It's a web application. Roughly looks like Google Maps on the first screen. So there's a map, because we thought, well, one thing we can say up front is that most of the things that they want to manage are somewhat location-based. So it makes sense to have a map to search. And then also there's this this search box down here where you can do a semantic search. So for example, if you're interested in functional programming, you can, it's a bit small probably, right? You can type in functional programming and you hit enter. There's a pin here, and then if you click that, you get sent down here. And then what you see on this as a search result is not a list of documents or a list of anything really. It's an excerpt of, or a look into this knowledge graph that is behind all of that. And I really wanted to express the idea of the knowledge graph being a graph graphically, and not hide it in any way to like make this feel like a document which you can edit as in Google Docs or whatever. No, I really wanted to have the people think in terms of graphs. Because the other things, they exist already, right? This doesn't exist yet. So what you see here is nodes, something like this, identified by a URL in this case. And then to the bottom and right, you have edges connecting to either other nodes or primitives. So here you have a type predicate connected to this event primitive. If I had internet, there would be Bob displayed here. This is just a string, Bob 2026. And for location, we refer to another node or another resource, also identified by a URL. And in turn, of course, we can have other predicates attached to that. So the location of Bob is, Bob 2026 is Scandic Berlin, and that has a street number, postal code, and so on. And all of these are schema.org predicates. If I were to click on them, and if there would be internet, I could read what location means. Yeah, so that's one thing you can search, and then every URL also is an actual URL that you can navigate to, and then you are presented with a detailed view on that. So you can traverse this knowledge graph just by clicking, as in the normal web. Go to the bottom right, or you can also go back. So there's this back reference link here, which brings me back to all the, or in this case, it's just one subject that talks about this as an object. Okay, we'll see more in a bit. So I want to talk about the architecture of this. And in the beginning, the backend architecture, which I want to focus on, was very simple, because Well, another reason for choosing this RDF or this semantic web stuff is because there's lots of pre-existing libraries and frameworks and other software. And so I don't have to invent all of that myself. There's a very good Java library, Apache Jena, which basically implements everything there is about knowledge graphs. And they provide you with a data type model, which can also which is basically the knowledge graph, right? They say model, this is the knowledge graph. You can configure it in such a way that it is immediately referenced to or persisted on the disk. So that's what I did in the first instance. And then for the search, I need geographical queries and fuzzy search vector lookups. I just use Lucene, another very popular Java library. Don't have to invent my own stuff there. So the code in the beginning, in the backend, was very trivial. Here we have a little example. So one thing that RDF provides is running queries in a special query language called SparkQL or Sparkle. There's Sparkle select queries and there's construct queries, and the construct queries are especially nice for the functional programmers' minds because they're essentially combinators. They take in a knowledge graph and they output a knowledge graph, usually a smaller an excerpt of that knowledge graph. And here we see there's a closure function, so it's a closure project. Run construct query, takes a model reference and a query and immediately passes that onto the Java library, which you can tell because it has a query execution factory, of course. And then for search, equally simple, I just use Lucene. So here's another function, search text and geo, takes in an index object, a text, a geographical box, a range for pagination, and then it returns a list of URIs essentially, which we can then pass to a Jena model in a special construct query to show you this graph that you saw at the beginning. And also the implementation of that is just using the Lucene library. And for change as well, so changes I defined as either, so there's additions and deletions of triples, or of these sentences, of these facts, or edges, you could say. So you can either delete an edge by naming all three parts, or you can add a new node, new sentence by naming all three parts. And then I run this by immediately, again, dispatching to the Jena library. And this function is called apply change set exclamation mark, and that's just part of the name, but it usually signifies or is closure code for this is a mutation or this is a side effect. And that's what it is, because I immediately use whatever Jena does, and that does in-place mutation, which is not too nice, right? Maybe we can do something about that. And then to populate the Lucene index, there's just a simple function that derives the entire index from a given model, and that's usually fast enough to do on every change. We could be a bit smarter here as well, but there was no need yet. So model to index is just also a name, right? We transform a model into an index. So all of this semantic web and RDF stuff is very nice for the reasons I told you, but there's also a fundamental issue, I think. And that is that almost every fact has a timeline. Something like Markus works for Active Group wasn't true 20 years ago. And it will no longer be true in, I don't know how many years, at the latest when I die. In the office, yeah. And the way this is, so it is maybe a universal fact because it names all three parts explicitly of the sentence, right? But it's not eternally true, you could say. And that's usually treated in a way that, well, knowledge graphs are just mutable state. So if this is no longer true because I retire, you just delete this fact from your knowledge base. And we saw that on the previous slide, right? I mutate this model that I have in place. And that makes me uneasy. So we can also see it in the API. So a dumbed-down version of the API looks like this. We have a search endpoint where we pass the fuzzy search term, a geographical area, and that is an effect because it might return different results at different times. And for the change, where we pass in these change sets, the additions or deletions, that mutates the knowledge graph in place, and that's also effectful then. So all of that is red. It's bad. So one way to work around this is the solution number one is what I would call statement engineering, because everything is something engineering at the moment. So I invent my own engineering discipline in that you can turn this fact, which is not really a fact because it's not eternally true, into another set of, or a different set of facts that are really eternally true. So here I introduce an event, a contract signing event, and I say I'm the signatory, Markus is the signatory. It mentions a contract, and the contract is an employment contract, and the contract mentions an employment start of some date that's not true for OPSEC reasons. And these 5 statements now are facts, right? So in a Platonic sense, even this last one would have been true 100 years ago, because at some point in the future it will become true. And certainly it will not go out of date. So if I now die or retire or whatever, I just accumulate a new fact that says, well, I'm not retired, but these are not invalidated by that. So as a pro, that's semantic web native. We didn't have to invent anything new here, just more statements. It also, I think, leads to, or would lead to simple architecture if we say that facts can only accrete, so in an event sourcing way, right? We never modify what's there, we just accumulate new stuff. But as a con, it's quite unwieldy for users, I think. So the link workers, they're not software experts that we provide this software for. And even for me, coming up with these 5 statements in a rigorous way was a bit of work. So I think that's not possible for my use case. And so, but another solution would be to, instead of mutating a knowledge graph and saying, well, it just mutated and queries are no longer valid that you put against it yesterday, I say that every knowledge graph is indexed by an explicit version identifier, and mutation is now just coming up with a new knowledge graph and a new version tag, right? So first con is that it's not part of the semantic web concepts. But as a pro, I think it has way less modeling burden on the users if we do this. And it also leads to, I think, quite a simple architecture, which we'll see in a few slides. So that brings me to the case for Git, or really any other version control system. So I don't want to invent my own. Yeah, please.
Sorry, you were saying the mutation is bar.
Yeah.
So, but that's not from. Is it from a user point of view, or is it?
Yeah, I think as well. Yeah.
So what's the actual problem with results changing?
Well, I mean, you have the problem in the human web as well, right? You have your website and there's some information, and then you look at the website tomorrow and the information is gone. That's bad for users, I think. Just that, yeah. And many more things. So it's bad for caching, it's bad for reasoning and stuff like that. But also for the users, because it just changes all the time. You cannot be sure that what you have will be there tomorrow. So by using Git, I don't have to invent my own mechanism, basically. That's the main reason. But then there's a sort of secondary reasons why I wanted to at least try out this idea. And that's, for example, bulk imports, so become quite trivial, right? So everything, so if I use Git, I have to use plain text files. And plain text files, so there's many plain text formats for this RDF, for these RDF graphs. I can just import them by bringing these files into the repository, commit, push, and it's done, right? Don't have to invent my own import mechanisms there. And then thirdly, users, they can also use the pre-existing third-party software that's also quite abundantly already in the world, such as things like Protégé. They can also just work with the plain text files, and I don't have to do anything to facilitate that. Okay, so demo number 2. So I've invented Git as a data persistence layer. I should probably plug in some here, charger. Can you do? I just noticed. While I do the next demo. Okay, so this application. Yeah. Perfect. So this application is hooked up to a remote Git repository, and on the right you see my Emacs, which is also looking at that. So this is the history. of that repository, and the files that are lying around are called .nt, which stands for n triples. This is the format that you already saw on the very first slide. Right, to make this a bit bigger. So here again we have sentences that are always end with a dot, and they consist of 3 parts: subject, verb, object, and subject and verbs are always URIs, and objects can be strings or other primitives or other URIs. Right, so here we have a node that has a name Bob 2026, and we see that in the GUI here as well. So maybe let's change something here. I didn't invent a story of what I wanted to change. I just type in something here. And the GUI then displays this as actually like a bit of a staging area, right? So this is not immediately persisted. It just marks this as a change. And you can also look at the before state again, if you want. And it says at the bottom, so if you were to commit this, this would lead to 1 addition and 1 deletion. So the old name is deleted and the new name is inserted. And I can also type in a commit message here and click commit change. And now on the right here, I can pull, and I see there's a new commit, FCBE. That's also what's on the top of this website. That mentions the current head that we talk about. And if I go back into this file, I see, okay, the new title here, of course, is also now Bob 2026, ASDJ, and so on. And the other way around, of course, also works. Let's put something different here. No, just delete this and make this into a commit, stage, and commit message, whatever, and push. Then, yeah, okay, it was quite fast. So in, I think, regular intervals, I just poll for the current head, and it changed up here. So now this is the head of 2C21. That's the one we just created. And when the head changes, we just reload whatever is displayed on the screen. And so you can see that the name changed here as well. So that's how this Git story works. And now let's look at the architecture of that. So this is the new API, or a talk version of that. In that the head, that's a new endpoint, right? That response is the current commit ID, and that is effectful in that it returns another commit every time, or possibly another commit every time you ask for it. But search now becomes a pure function because, well, there's still a fuzzy search term and area, but now you also have to mention the commit ID explicitly, and that doesn't change anymore. Right? So this becomes a pure function, no more effect there. And also, I think the change endpoint becomes a lot simpler. So it now still takes a delta, so a list of additions and deletions, and it mentions a base commit. So what do we want to base this change on, which commit? And it responds with a new commit ID, so if everything was successful. And it has a little effect, but only a little effect, right, in that it sets the new head. But this could easily be decoupled, and in the backend, it is actually decoupled just for convenience sake. I put it into the API in one go. But the change itself could also be more like a bit more like a pure function if we were to decouple that. So let's look at how that's done. So that was our before state, so where I just used the Apache Jena model, persisted on disk, and just used the API that Jena provided me with. So that is our source of truth, persisted on disk, and we derive the Lucene index from that. But now we want to have a different source of truth, which is this local Git repository, which is basically just a set of files, right? And that lives on disk. And the Jena model is still useful because we want to run Sparkle queries, but it is no longer the source of truth. It just lives in memory for querying. Similarly with the Lucene index on the right. So here's how that would look. So there's a read effect, which takes in a commit ID and a repo URI, gets the corresponding files, which you call folder here, and then there's a function folder to model, which takes these plaintext files and puts them into a Apache Jena model in memory. So lookup and search becomes quite trivial to do now. I think even simpler than with the mutable thing. But change is a bit more complex if we want to do it in a performant way. So in the worst case, someone opens up their editor and or clones the repository, manipulates these files that belong to commit A, commits them, pushes them, and then we end up with the commit B. So the files changed, and then the corresponding Jena model, of course, also has to change. And so in the worst case, we just have to derive the Jena model in its entirety from the new set of files. So if someone did that mode of operation, then we have to do that and call the folder to model function, which might be expensive, right? But most changes are probably be done still through our API by the front end, by people working with the front end. And there we can be a bit smarter. So what we could do is the analogous to what we just saw, is that there's a function folder apply change set, takes in a change set and moves a set of files to an updated set of files, right? And then we could also still do the same thing where now we have to call folder to model and the implementation is done, but that's probably too expensive to do every time. But we can easily come up with a function that also goes the other, goes this path, going from an old Apache Jena model, taking a change set to a new Apache Jena model. In fact, some version of that already existed, right? So in the former version of the project, something like that existed in some form. But now we have to be very careful that these two match, right? That this is an analogous, or this is an analogon of this function above. But I'm always happy if I see these kinds of graphs here, so these diagrams, because they usually mean that we can define a very good correctness criterion. So let's say we want to say, when is Jena applied change set correct? Well, we could say it's correct in the case that if we start with a set of files here, and we go first this route by going through this folder apply change set, and then say folder to model, we end up in the same with the same value as if we were to go the other route, folder to model first, and then our Jena apply change set that we want to define. If that matches for every set of files on the top left, then we have a correct implementation. And that's a good base to start for doing a formal proof, maybe, which I didn't do. I wrote some property tests, and here you can have a bit of a view, look at what that may look like. So this is defining a macro to make these things easier. I didn't draw this or put this in just for the talk. This was there already, which I was quite glad that I drew it in ASCII. So whatever you see here is also here in ASCII as well. And here you see folder to model of a folder, and then Jena apply change set should be the same as folder apply change set for a given folder, and then folder to model. And this is just for the test model to NT on both parts. So this might be a complicated setup, but at least it is easily, the correctness criterion is easy to define. And that's also always a good place to be in. So this is an open source project, so if you want to see more of the code, you can just go to this GitHub link here. And if you want to go into more depth, you can book a training with us maybe. So it's not just that we do software development, we also do trainings. And this is a part of our website. So a lot of what we do is centered around these ISAQB training courses, the most popular being the Software Architecture Foundation, where we also have another very interesting case study, which that 4-day course works around. And I especially want to draw attention to this date here. So in May, on-site in Stuttgart, in German, there will be 4 days of training around this Software Architecture Foundations that I'll do, and it will happen if enough people sign up, let's say that. So I would be very pleased if you're interested in that and have an employer who can pay for that, then talk to us. So as a summary, linked data provides a flexible distributable data model, which is good, but it's ignorant of timelines. And so that's where the two parts of my title meet, right? So Git or other VCSs for that matter provide simple timeline management tools. And if these two come together, the resulting architecture, I think, is quite nice for users and for programmers. Because Git cannot just be used for source code, it can also be used for application data. Thank you.
when I think about timelines, I always think about cross-time-DB and their model of bitemporality, where you have one domain for when you changed something and one domain for when data was valid. And your Git approach is a very good approach for this when data changed, like the application changes. And for the RDF data itself, there is the RDF star extension, which also allows these data as valid from then to then. Did you consider it just to use that, or would you use that to extend?
Yeah, I think the RDF star or these extensions, they have the problems that I mentioned, that they put a lot of burden on the users, I think. So they have to think about when is this valid, which is usually, I think, people don't think in these terms. I mean, I already put a lot of pressure on them by saying, there's a knowledge graph, you should know what that is, and you have to work with it. And now I also have to additionally say to them that you have to think about the validity timeframes and so on. I think that's a bit too much for that project, but yeah, sure, it would be.
But could you just start with when you enter the data, the validity starts, and when you remove it, you remove the validity?
Oh, so you mean as an implementation?
Yes.
So, yeah.
So you hide it from the user.
I didn't think about that.
Okay.
Maybe but what would that gain us? Would that be? Or maybe it is. Then it's semantic web native.
Yes.
Could be. Yeah, that's a good idea. Yeah, maybe I should.
It's a standard.
Yeah.
I mean,
The 16th or the 17th standard? 16th or the 17th
and
standard?
RDF star is quite new.
Okay,
I'm
the
not
17th.
sure about
Good,
that.
good to know. So, are there other questions? No. So, if I understand it correct, like I remember, like even 17 years ago, like governance or provenance of RDF triples was always an issue. Like I remember it, like always. Like then, like people came up with ideas like you introduce a URI for a triple, and like then you adjust governance data and all this kind of like everything. Like I saw it. Yeah. So what you did basically, you did use Git now exclusively to kind of track this timely dimension. You're not tracking who, for example.
No. Yeah.
Okay.
Could maybe integrate that somehow as well, but yeah.
And you also showed, you also showed basically the serialization format, because serialization format is your key, kind of, right? You must not make mistakes there because things go wrong, like lines go out of place or that kind of thing, right? So I saw there 16.nt. Why 16?
That's just I had to split the files because they got so large.
Yeah.
So it was just a random.
Yeah, if I got the idea correct, like very implementation wise, what you program most of it, right?
Yes.
Okay. You basically built an index of subjects in Git. Is that correct?
Index of subjects.
Because each file is a subject. Is that correct?
No, I
No,
don't think
you
so.
split arbitrary.
It's group. I don't recall.
Okay.
I think it's rather arbitrary. I didn't want to commit to any grouping it by anything.
Good. Thank you very much.
Yeah, but of course you have the problem of if you manipulate it by hand, the plain text files, there has to be some reading of that, and then if you serialize it back out, it is a completely different structure. I didn't make any attempt to keep most of the structure. That brings you in Hell's Kitchen.
Exactly. Like I was immediately because I tried these things. I was once creating software code for OntoWiki. It was called OntoWiki from University of Leipzig, and we had all these problems all the time.
Yeah. I did go there. Yeah, please.
Thank you. You showed us the difference between the front-end changes and the changes in the console. Are there null checks? I just wondered, like, can you enter an empty name?
So you can just in a plain text file you can do all sorts of wrong things.
Okay. So
you have to do something like, I mean, that's the pro feature, right? So going directly to the repository. To be honest, I mostly did it for myself because I wanted to initially fill it up with some data, right? And that was just a very convenient way to do it. So you have to be careful to not break the system. There are some minor safeguards to work with that, but some human have to fix that. in the end. If
Because every time users are involved, I wonder about how to guide them, basically, in not doing
so the users going through the API, they so that would be a bug if they could bring the system down in this way, right? But just by going directly to the plain text files. I say that's a user error then, and an expert has to fix that. Is this the time?
No, another question?
Yeah.
Would merge conflicts realistically arise?
Glad that you asked. So, yeah, I implemented a basic three-way merge, which is, I think, the three-way merge to do with sets, right? These are just sets of these tuples, and sets can be merged either two-way by unioning them again. But that would, in this case, so if you say someone made this change or ended up in this state, and the other one ended up in this state, by by calling a union on them, the triangle would come back to life, and that's probably not what the user intended going to the right? They want to delete the triangle. That's what they did. That's the change, the delta they sent to the back end, or did it in the Emacs. So I do a three-way merge where I merge the changes. So the star is added on the one side, and the circle and the triangle, the circle is added on the right, and triangle is deleted. So merging those changes ends up with the change where all the three are present, and I apply that, and that's the result of the merge. So that's one auto merge that I just do all the time, and that means you end up with, so if one changes the name from A to B and another from A to C, then you end up with with two names, right? So both B and C, and that's fine, I think, for this application.
Question?
As for illegal values, you could always use Schlegel or something like that on pull requests. Have to question like illegal values that you could enter.
Illegal values, Schlegel, yeah.
Yeah. One question.
Yeah.
I find this very charming as an approach. You juxtapose this version control with modeling the start of your deployments as a contract signing approach, more or less. Have you ever looked into the conventions of start dates and end dates as they're used in Wikidata? For example, it could be prudent for you, or let's phrase the question differently. Does your model work if you have to refer to events that happened in the past that are no longer valid? For example, if somebody was born in a city that was part of the German Democratic Republic, which doesn't exist anymore, but it's relevant to model that information for their, I don't know, for their vaccination or whatever.
So what the question is, did I think about that, or what is the question?
Would this work in your version control scheme?
No, I think that's orthogonal. I think it's an orthogonal concern, or maybe not an orthogonal concern, but the implementation is at least orthogonal here to what you say. So users could still do what you're suggesting to be the key. I think that, yeah, so somebody like that has to happen at some point. It didn't come up yet, but yeah, you can still insert this information, but that the Git doesn't care about that. It's not integrated. Yeah.
I quite like this. This is probably overkill, but have you thought about sort of like the concept of like working locally and then pushing? Like this context, I think is overkill, but I think it's quite nice that you can check out the repo locally, you can make changes offline.
Yeah, you can do that. Yeah.
So in this architecture, is the change always applied on like a central server immediately, or is it that the client, whatever that looks like, the web app?
Yeah. So this web app is terminally online, so it always immediately pushes or tries to push, but yeah, the power user can just clone the repo and go offline, however they like, and you could come up with an implementation of the web app that also does something like that, works offline, but or you can self-host it, for example, and then implement that yourself. Yeah, that's possible.
Sorry, out of time for now. Take it to a break. Thank you again.